figure, in this figure, we are plotting data points. This data has only two features in this data set. So there is an x-axis, there is a y-axis. So my goal is, can I create a certain boundary so that if a new data point appears on this graph, can I tell whether this data point should be red or blue? Okay. So this is my training data set. I have this data set, and these data points are labeled already, red and blue. They're already labeled. Now, if a new data point appears here, what is the label for this data point? Should it be red or blue, right? That is the question. Now, before even getting into that question, answering that question, first of all, we should notice something here, right? If you look at the y-axis here, the numbers are changing from -1 to 6. If you look at x-axis, the numbers are changing from 8,000 to 12,000. Now, before even dealing with this data set, I need to do something about these numbers, because apparently this is gonna be really dominant. Now, if you make scaling, which we are gonna see later, means if I turn these variables, 8,000, 12,000, if I represent them as numbers changing from -1 to 2, and similarly, if I change these numbers, which are changing from -1 to 6, into numbers in a range from -1.5 to 0.5, in this case, then I have balance in both axes. So then I can work on this. That is called scaling, which we'll see in a moment. This is the effect of not doing scaling. When you run, this is one machine learning algorithm. I'm trying to determine the regions which I will label as blue or red. Okay. So if I don't make scaling, this is how I'm going to be finding the regions. Because this is so dominant, x-axis is so dominant, y doesn't matter. I'm dividing the region in terms of how x-axis is changing. If I make scaling, as you see, it makes sense, right? Now, this portion of the figure is blue, labeled as blue. The upper portion is red. There are some errors, we'll see later. Of course, you expect some errors in your model. The goal is reducing the amount of these errors, but not overfitting, and we'll see what overfitting means again shortly. There are different ways of scaling the data set. I'm not going to get into detail, but again, another example to demonstrate the impact of scaling. So this is the original data set. Again, there are only two features, x and y. Right? One is changing from 10 to 15, the other one is changing from 1 to 10. So if you scale this data set, as you said, the figure is kept intact, right? So this is standard scalar. What you do is, I'm just going to explain this one a little bit. What you do is, you look at your data set, find the average of the entire data set. What is the average of this data set? Let's say this might be age, income. What is the average of age for everybody? Then subtract this average from everyone, and also find standard deviation, means how the age is distributed, right? How wide that distribution is. That is called standard deviation. And divide that by standard deviation. So age minus mean of the age for everybody, divide by standard deviation, is going to normalize this data set. Everything will change from -1 to 1. Again, it's a mathematical thing which you can look into later on. Just one way to scale the data set down.